welcome back to another episode of Data Protection Gumbo. I am Demetrius Malbro, your host, and once again, I am super excited about the guest that we have on today. And I have Eric Daimler, who is the CEO of Conexus, a revolutionary solution that tackles the modern day challenge of data deluge head on. And a little bit about Eric is that a fun fact about Eric, right, is that he served under the Obama administration as a Presidential Innovation Fellow for AI and Robotics in the Executive Office of the President as the sole authority driving the agenda for U.S. leadership. So, Eric, we want to know all about that. So, welcome to the Gumbo, first off, and glad to have you here.
Oh, thank you. Thank you for the introduction. It's good to be here.
All right. And yeah, why don't you tell us maybe a little more about the your experience, right? Back the Presidential Innovation Fellow for AI and robotics and that whole experience. And is that something that we should all look forward to one day if we have an opportunity to serve as an executive office of the president?
It was a privilege. I tell you, I came into the U.S. government with as much cynicism as anybody about the bureaucracy, but I was really surprised by the drive and intelligence of the people I had the good fortune to work with, especially in that administration. And I'm also happy to say that even after that administration, for whatever other controversies emerged, the work around AI had expanded. And so a colleague of mine, Lynn Parker, was actually able to expand the efforts around AI into a whole AI initiative that continues today. And the whole science advisory group has been elevated now to be a cabinet level office. And it would certainly be my privilege to go back and serve the American people and their allies through that government service should I get the opportunity in the future.
Okay, nice, nice. And you are also you're the founder as well of Conexus, right?
One of three co-founders,
Okay, one of
correct, with
three.
Dr. Wisniewski and Dr. Spivak. Yeah.
Okay, tell us more about Conexus before we dive into some questions here.
Conexus was a discovery in math, based on a discovery in math by Dr. Spivak, as math faculty at MIT. And to have the Institute tell it, it is the first ever spin out of the Institute's math department. There has been a discovery in mathematics in this domain, this abstract math called category theory, that Dr. Spivak then applied to databases. So this doesn't
Yeah.
sound too or maybe it's not too esoteric with math and abstract math, but I came to find out about it when it was really just this nascent research idea, and I was working with the White House, solving some of the biggest problems at scale for AI. The underlying problem of AI is not terribly sexy, and certainly not as telegenic
Hmm.
as the the, the chat manifestations we see today, or the
Right.
video manifestations we see over the past week that just got introduced. It's in the underlying data that powers those technologies. AI
Okay.
is about uh, using data at the top level, but underneath, it's of no value if you can't bring data together. This
Okay.
means running power plants. It means designing airplanes. In our particular case, motivated by NASA and the Defense Department, it means shortening the time cycle, reducing the cost, and improving the integrity of the development of rockets. That's what originally catalyzed the fund development of this technology. And that's what Conexus AI does commercially today.
Yeah, that's all fascinating. And you mentioned data, right? So AI wouldn't be possible without large amounts of data, i.e., large language models, and that's how the whole training and feeding of I like to call it the beast, right? You have to have tons of data in order to give AI the information and the bits and bytes to learn, so it will be, I guess, intelligent enough to provide a response back that is not a hallucination, right? Which is what I like to say. But as far as the data is concerned, and that's the number one aspect of what we're trying to keep safe because there's a lot of bad things out there right now, cyber attackers out there, you have ransomware out there as well. But I really want to get your view on maybe what are some of the reasonable expectations for AI, especially in the current business landscape, and also for everyone who desires an unbiased AI system.
Don't we all want unbiased AI systems? Wouldn't that be just lovely? Yeah,
Yeah.
I can start there. Unfortunately, that's very unlikely to happen in many, many, many circumstances, and it's because humans are involved and humans
Hmm.
have biases.
Yeah.
Somehow, to try to remove our biases is going to be, just hopeless. It's funny. I just got back from a trip to India where I was speaking with a group of real terrific people about this subject in AI, and I went over to India with some biases. I had biases about the chaos I was to expect in Delhi. I went over with this bias that I would be running into these intelligent people generally with a lot of technical training, on average. And,
Yeah.
that's my bias coming into the country. And some of those were fulfilled and some of those were modified, I guess, or dispelled. But I have biases. I'm human. So we can first talk about the biases of data. You're going to bias somewhere. I think the more reasonable answer is transparent about it or aware about it. But I can talk about the implementations of AI. And the summary for that is the right tool for the right job. There are different types of AIs. And
Okay.
everybody's gotten the memo of data's the new oil and all that. We need to collect a lot more data. But
Right.
while the hyperscalers, Microsoft, Oracle, AWS, and so forth, send you a bill at the end of every month based on the data they collect, you don't really care about how much data you collect relative to the data you can use, right?
Right.
And,
Yeah.
and so that's where that term dark data comes from is you have data that you've collected and data that you don't use. So there's the tool that would allow you to bring more of that data to become available to you. That's what matters. It's a little bit like the proverbial drunk looking for the keys where they lost their light, or where the light is. You use we work with a money center bank that uses our product for risk management, and they know that they're only using a portion of the data that they have available in this very large global bank for their risk management. That is just using a portion of the AI tools available to them, absent Conexus AI, that impairs, absent Conexus AI, their risk management. So what they want to do is they want to use a broader suite of AI tools like Conexus AI to
Hmm.
make more of that
Hmm.
data available and enrich their risk management. It leads to greater effectiveness, decrease in their inefficiencies, and decrease in the reserves they have to hold, in addition to the visibility they have around their risk management. So that's just an
Okay.
example of appropriate tool for the job, bringing more the appropriate AI tool to the job to enrich the expression for a particular application. That's kind of a people application of AI. You have to have a person interpreting
Yeah, you
this
do.
data based on the appropriate AI brought to the work.
Yeah, all great points there. And you mentioned a few different kinds of AI, right? And most people only hear about Chat GPT, right? And large language models. And there's so many little products out there now, so many little like video products and helping you create content and write and all these different types of things. But the world of AI, it's so large, it's so huge now, and people are capitalizing on artificial intelligence and learning about prompts and prompt engineering, etc. But I want to get your perspective on, and I don't know if you mentioned this, deterministic AI. Like, how does that differ from some of the more popular foundational models of like deep learning? And also, in what ways is it more suitable for addressing some of the high consequence and life critical type environments?
Yeah. Speaking via audio and not video, we'll do our best to create a visualization here in
Yeah,
distinguishing some of those terms.
I can
So,
add
you know,
something.
the
Yeah.
the the current expression of AI often finds itself popularized through large language models, which is an expression of these neural networks, which is itself a subset of machine learning, which is itself a subset of AI, a probabilistic branch of AI. So we can dissuade anybody from ever using the term machine learning and AI. It's kind of nonsensical, or deep
Okay.
learning and machine learning. Kind of, it's nonsensical. We just say there's a probabilistic branch, but also there is a deterministic branch. You can say that one of them, if everybody can recall their high school logic courses, where you have induction and deduction. So induction is where you take a specific and you move to a general, and deductive is the other way around. So
Hmm.
where you'd say this animal has wings, this animal has wings, or this bird has wings, this bird has wings. Therefore all birds have wings. So you move to a
Yeah. Yeah.
generalization, right? That's an
Hmm.
induction. And you notice as we go through that example, if I had a million birds with wings, we're still looking for the possibility of the proverbial black swan. Use the things popularized from a couple decades ago. That's the nature of testing. There's always a possibility of an error. So you don't want to be betting your life on that sort of proof. But then you have deductive proofs, and the deductive proof work in the opposite directions. You'd say all birds have wings. This animal has wings, therefore it's a bird. Right? That's deduction. That's like
Okay.
straight up
Yeah.
facts. There's kind of no dispute
Hmm.
about it. That there's no error bars in that. If you establish the fact at the beginning, all birds have wings. This animal has wings, therefore it's a bird. Like that's the Sherlock Holmes straight up. This is the conclusion, no doubt.
Hmm.
Put the murderer in jail. The
Yeah.
Sherlock Holmes
Yeah.
analogy, right? You have to use those in combination in many circumstances, in many ideal circumstances. But this is where we go back to the beginning to say we use the right tool for the job. The deductive part is what Conexus AI really focuses on. We focus on these high consequence contexts. You're building a rocket for NASA, you're building an airplane for Boeing, you're designing and deploying a power plant and putting up towers for windmills, or designing oil rigs. This is stuff where bad things can happen if
Yeah.
if you get it wrong. It's not like digital advertising or the six finger problem in a video. I mean, there's real
Hmm.
consequences. That's why the right AI for the job is really where we look. So those other two, a better way of characterizing those, perhaps a way that
Yeah.
it can be more intuitive, is we talking about people, and so people, context around AI is an important level set in many of these technologies. But the way of thinking about induction and deduction could be the difference between principles and patterns. So patterns could be found in data of any kind, and then principles you could say are your rules. So I have
Okay.
rules for what my power plant needs to look like. These are principles. These aren't just guesses. They're not something. I'm not going to run my power plant again off of ChatGPT. These
Yeah.
are actual principles that I'm going to establish based on the expertise I have over many decades and the potential loss of life. Those are principles. So we work with an energy company that integrates the databases for their windmills in one particular
Hmm.
case,
Hmm.
where they have databases for maintenance, for installation, for operations. Those all have to be integrated in a way that has provable completeness. That is AI for principles. And then on
Okay.
patterns, one of our clients is Uber, where they have at a high level ordinary business intelligence questions. Supply demand. How does the rain prospectively for San Francisco this weekend going to affect driver supply and rider demand? Underneath that is data. They need to look at the underlying data across their databases for the region, let alone the country or the world. Those are patterns we need to analyze. Uber is important, but it's not kind of life critical in many of these in
Yeah.
this
Right.
way.
Right.
But what we did is we integrated, in their particular case, hundreds of thousands of databases, so they could automatically do those sort of or add some alacrity to their ordinary business intelligence questions, and to
Okay.
have them tell that you save them 10 plus million a year based on the alacrity with which we're able to answer those basic
Okay.
intelligence questions. So
Yeah.
the loop. I'll say one last thing here. So the loop of AI is you're going to start with principles, and then that feeds into looking for the patterns, and then that it gets back to the people, and then the people put the context around it, put the kind of the sanity check around it, and modify whatever they need to back into the principles that then fed back into looking for patterns that then fed back into the people. So that is the circle of a modern AI system: principles, patterns, and people.
Okay. Yeah, I appreciate that educational tidbit to kind of break that down and explain induction and deduction and the whole idea of people and process and all of that around AI. Now, you mentioned rockets and building like some of these larger, really mission critical type systems or whatever, but what about the smaller guys, right? So how can smaller companies or organizations or enterprises leverage AI without so much, I guess, resource investment because it could get time consuming and expensive, especially to hire talent nowadays for AI because everyone is like racing for an artificial intelligent type product, right?
Well, there's a lot of applications. The first on the first order, I can just suggest that people experiment with the various
Hmm.
AI tools that are coming online, and a lot of them are coming online seemingly every day, every week, if not every day.
Yeah.
So just experimenting in whatever processes you have. The discipline of of constantly improving is really probably a new skill set that everybody needs to nurture for themselves. The skill set of the next decade is going to look a lot like the disambiguation. Getting rid of ambiguity. The CEO of NVIDIA came out a while ago and said, "Oh, I don't need to encourage people to do programming, and the future programming languages," and this got widely misinterpreted
Oh, yeah.
because what I think people took away from it is that they could just be talking to a computer in natural language, and the computer would understand what they're trying to say. That's not what
Hmm.
he meant at all.
Okay.
What he meant is that you don't necessarily need to learn the syntax of machine code or machine language, assembly language, or C++, or even Python and Java in our modern expressions of computer languages. You don't need to
Hmm.
learn the syntax. But you tell me what you would call the manipulation of a computer using text. You call that programming. Whether it's
Yeah.
in
Right.
Python
Right.
or Java or English, kind of doesn't matter. What
Yep.
you need to do is you need to tell the computer without ambiguity exactly what you want it to do.
Mm.
So coming
Hmm.
back to your question about the
Yeah.
deployment of AI tools for even the smallest businesses, what people need to do is they need to practice deciding in their systems, whether this is a small system or it's a little larger system as part of a much bigger system, exactly what they want to do, exactly what they want to then automate. And
Okay.
then they can determine what the most appropriate tools are for that task. This isn't magic. You can't just sprinkle some spice on it and
Hmm.
sprinkle some AI on it
Some
and have
gumbo.
some output comes out. The computer exactly. The computer is going to do exactly what you tell it.
Right.
The gumbo is going to turn out exactly how you cook it. So so what ingredients you're going to put in, and you need to tell me exactly. There's a certain nuance in our artistry for messing around, but for a computer, it's going to turn out. There's nobody to blame but the chef for how the gumbo turned out.
Right. Yeah. Yeah. Wow. That's I don't think I've ever heard it put that way before because it depends on the different spices, right? And you have to know how to make the roux, right? I don't know if you've ever made roux for gumbo. You have to stand there and stir it, or else it'll burn, and it has to be at the right temperature. But I know we're getting off topic here,
That's
and
not off topic at all. I mean, that is just right on topic. It's actually a lovely analogy.
yeah,
We can keep
yes.
going with that for the rest of the time we have.
Yeah. Okay. Okay. And I also wanna at least ask you about something that I don't hear a lot about it lately. And plus, besides Elon Musk and all the things that he's doing, because he's kind of a one-man show around saying what he wants and doing what he wants because he has enough money that he can probably do that, right? And what about autonomous driving and like fully autonomous driving and the timeline on maybe some of the deployment autonomous technologies? Because I'm assuming that there's still an evolution from that perspective that's happening with the whole EV industry, et cetera. Do you have a perspective on that, Eric?
I do. I do. I guess I have a couple of informed perspectives on this because
Okay.
literally I took an autonomous car to work today. From
Okay.
my house, I got there's autonomous cars passing out in front of my office every few minutes, and I took
Without
one of these,
without
a
a human.
Waymo. Yeah, yeah. Nobody in the drive, nobody else in the car but me.
Wow. Okay.
And so how this works is I pull up my Waymo One app. The car tells me where it's going to pick me up, and then, which is a little aside, you can clearly see that the company had negotiated with the city about where is safe for these cars to
Mm.
potentially pull over and not block traffic. So
Mhm.
it doesn't pull over the same place as an Uber would be. I have to walk like 50 yards or something to where it's a little bit of a side street. And then I press the app to unlock the doors. It's a Jaguar electric car, the model number, but whatever,
Okay.
the electric
Mhm.
Jaguar. I get in and then I press this. It welcomes me, which is nice. Hello. Yeah. I press the start button and it goes. It tells me to fasten my seatbelt. Who knows if I didn't do that, what would happen? But it then it tells me it goes without me interjecting anything up until me being close. And then when we get close, it says we're almost arriving. It stops, and then I open the door, and I get out, and it's easy as that. You can tell how these have gotten better over time because I've written in autonomous cars for many years now, not with the same frequency, of course, but they've gotten a little more aggressive because there's a
Mm.
certain social norm about driving where, hey,
Right.
if somebody's going to pull out, pull out, don't hesitate too much, or I'm going to move
Mhm.
around you, right? So the car needs to go if it's time to go. So
Right. Yeah,
you've
yeah, yeah.
definitely noticed it going now more than it used to. But I can challenge your listeners to think for themselves when the first autonomous car was on a U.S. public road. So this is a car on a U.S. public road driving completely without it by itself, without anybody in the driver's seat. Some people say, well, was that 2015? Was it 2010? Was it 2005? Was it 2000? When was the
Mm.
first autonomous car on a U.S. street? And
Completely by itself.
the answer, completely by itself. The answer is 1983.
What?
So this was going 5 miles per hour. It was clear. It was dry. It was bright. So, and it's in a van with probably more at the time, more computing power than the entire developing world, I think was the joke at the
Mm.
time. In Pittsburgh, Pennsylvania, at Carnegie Mellon, this is actually why ended up choosing Carnegie Mellon over Stanford and MIT because it was leaders in
Yeah.
autonomous cars, and it cut the fascination of a teenager at Daimler. So that's where I decided wanted to go, and then
Okay.
pursue ultimately my PhD in computer science. The point about that is this technology in a physical realm, automated technology in a physical realm, is really hard. And it's actually, in many ways, much harder than purely digital technology.
Mhm.
So while there's been many improvements in digital technology over the years, so you and I have benefited from ABS, we have benefited from traction control, we've
Right.
benefited from distance controlled cruise control, and then lane control on our cruise control, and some cars will even correct you in your lane.
Right. Mhm.
What that is just improved little by little by little, and so but some, Elon Musk's marketing claims next year will be fully autonomous driving. Next year will be fully
Right.
autonomous
Yeah.
driving. Those of us in the industry always knew that was a marketing hype. I think we were hopeful that it might be coming, maybe sooner because there are a lot more resources going into it.
Mhm.
It isn't going to be here next year. It's not going to be here the year after that. And if we're hoping for the proverbial sofa driving down the freeway, or we're just
Yeah.
watching a movie, that actually literally may never happen
Yeah.
because there's just too many edge cases. I think the idea is that this is just going to get easier and easier, and or offered in more and more controlled environments.
Mhm.
I can offer one more thing.
Yeah, sure. Go ahead.
you know, Google, in response to their threat from OpenAI, they killed off their autonomous trucking program in order to dedicate resources to the compute required to compete against OpenAI. Google now allocates an unfathomably large amount of their global compute, 60%, to
Hmm.
training their large language models. They've done that
Yeah, I
since
can believe it.
October of last year. 60%.
Hmm.
This is weirdly large.
Yeah.
In order to do that, they had to salvage hundreds of millions of dollars from other departments, one of which was autonomous trucking. And the disappointing part about that was that autonomous trucking was an area where Google even had greater leadership than they do at Waymo One. Autonomous trucking, to some extent, is an easier problem to solve
Yeah.
than
Right.
autonomous cars, because for the vast majority of long haul trucking, you are one truck driving down a freeway in a controlled environment. So that's a much
Hmm.
easier problem, and it actually would have a much bigger impact on safety for everybody involved,
Yeah.
on
Right.
emissions, because it just adds to the efficiency with which these trucks are driving for a variety of reasons we can get into, and also the quality of life of the truckers, because long haul trucking is really not a great job.
Yeah.
Not
Right.
not just the stress and the sleep schedule, but to
Hmm.
hear long haul truckers tell it, it's the drain on their relationships, being away from friends
Yeah.
and family for long periods of time.
And their
So it's
health.
unfortunate that that whole yeah, and their health. It's unfortunate that that part of our future is probably delayed somewhat because of the way Google responded. That's my perception about the
Yeah.
physical expressions of autonomy relative to purely digital expressions of autonomy. It's a little harder in the physical realm.
Very interesting. And I think San Francisco may be the only place that has the autonomous cars with Waymo, right? Is that
Phoenix, and San Francisco.
Phoenix? Okay. All right. Yeah. I've yet to take a ride in one of those things, and I don't know if I would be willing to do that or not. I'm sure I probably would. There's maybe a little bit of excitement to knowing that you are in a vehicle and it's just a computer, and you kind of trust pilots to fly a plane, right? And I don't know, maybe we can talk about that later around like how does it feel to ride in one of these vehicles and what are you thinking? And maybe you've done it so many times that it's just no big deal now. It's like jumping in the car with an Uber. But
Just on that point,
yeah.
I've had other people in the car with me, and just to have watched my wife do it for the first time recently. So she hadn't been in many of the previous rides over the years, but
Mhm.
recently she was very excited to do it initially. He was taking videos and so forth, but I think it didn't take 5 minutes for her to then just get bored and sit back and to start playing, working, checking email or something. She was over it. It did
Yeah.
become boring, I will tell you, very
Yep.
quickly. That's how these cars are designed. They're not designed to drive like a New York taxi cab, right? They're
Right.
designed to drive
Safe.
smoothly and safely, setting expectations for the driver and for the passenger and for other drivers, right?
Right. Right. Yeah. But yeah, I do appreciate you taking time out of your day to jump on the gumbo for us and to give us some insights around AI and a little bit about autonomous driving as well, and just some of the exciting things that Conexus is also doing in the space as well. And before I let you go as well, I want to just put a plug in for the group on LinkedIn that I run. It's called Backup and Recovery Professionals. There's almost 26,000 people in that group now. So please join the group. We're having similar conversations around artificial intelligence and data security as well. So please join the group and jump on so you can have some conversations with us as well. And any final shout outs or outgoing remarks that you'd like to leave, Eric?
Conexus.com is where you can find our firm for anybody dealing with the challenges of data integration or automating data engineering. It's a good place to start for any people looking to build their skills in AI. I could just encourage the pursuit of certainly probability and statistics, which you've talked about before, but also in the abstract math of category theory, which is less intimidating than it sounds.
All right. Well, Eric, thank you again. And I appreciate you being a guest right here on Data Protection Gumbo. So thanks for tuning in, everyone. And we'll see you next time. Stay secure and make sure you back up often.